All right, so that cache is done. Let's just click load from disk, and you can see that it's kind of hard to visualize. So let's throw down a volume visualization and just wire this in here. Let's add our density attribute to our visualizer here. And I'm going to just increase the density scale until it's something that we can see. And we can see, let's just get back into our camera here. Yeah, we can see the smoke sim playing out. Now it looks here like with our new settings that this pyro is not actually reaching the toe anymore, which is kind of a bummer. So I'm just gonna have to rerun this. The sim only took about 3 minutes for my computer to compute, but it's just the nature of the business. So I think what I'll do is actually go back to our pyro sim over here. And in our source density, I might just crank up this temperature a little bit more and see if that helps fill things in a little bit. I'm going to hit escape and go back to frame 1. Also, I'm going to name this volume source our collision, just so that we don't get confused about it. I'm going to just turn down the uniform divisions for a second and just see if that temperature is helping us get any more, helping this fill out any better. I mean, so it looks like it's doing a pretty good job on our actual low-res sim. So maybe I'll just crank this up to 450 and just run that sim once again. So again, I had just increased the scale of the temperature up to 0.1. And now I'm going to run this again at 450. Let's look back to the pyro cache. And let's click Save to Disk. All right, so now that that cache is done, it looks like it is filling up our shoe properly. Cool. So now let's just take a look at what like maybe our attribute what our sim looks like out here towards the end. It's looking pretty cool. We could modify what this color is doing, but I actually want to leave this as a grayscale value so that whatever Alembic file I create at the end of this, I can modify the actual these color values in the shader in Cinema. So I just want to double check and make sure at the end here what our actual color range is. So I'm going to set this back to a black to white value and actually handle the modification of the color using a point VOP separately from this node. That way I can kind of just know here what my color range is and how I can use that later on. So it looks like it's actually still staying mapped reasonably between 0 and 1. Actually, it looks like it's going up to 1.6. So that's clipping. And I want to kind of manage that so that it isn't doing that. So I'm actually going to change this input range back to 0 to 1. So this is the true range now. It looks like on the last frame, it's ranging from 0 up to 0.25. So if I bring this input range down to 0.25, we're going to get values that are closer to 1 in the end. So more of a true grayscale from 0 to 1. So now that I have that mapped to my color, I just kind of gonna go through and spot check a little bit. It looks like we still have values that go over 1 occasionally. Maybe on the second frame, you can see that we still have values that go all the way up to 1.5. So I'm going to just change that input range to 0 to 1. You can see that it looks like it peaks at 0.38. Just kind of things you look out for in the attribute spreadsheet. So maybe what I'll change this range to is something from 0 to 0.38. Something like that. That should leave us with a pretty decent color range between 0 and 1. And so now I'll just apply a little bit of that. I could apply a little bit of that attribute blur right here, but I actually want to cache this out as a mesh before I do any blurring after the fact. So let's just throw it on a file cache here. And we'll call this the Pyro Surface. Pyro Surface cache. And I'm going to copy this file path that we did up here and just paste it in down here. And I'm going to run that, and I'll be back when that is done caching out. that is done caching out, I'm just going to click load from disk here. And maybe I'll just collapse down this. And let's go, and I want to visualize the color again, so I'm actually going to create a point VOP to do what we were doing up on our attribute from volume. So point VOP, let's wire it in down here, dive inside, let's bind in. We're going to bind in the temperature, and we're going to throw it through a ramp. Sorry, we're not going to bind in the temperature. We've already bound the temperature to color. So we're actually just going to throw the color through a ramp. But I'm going to break out just one of the vector components of the color. Because if I wire color into the ramp, you can see it gives me this dotted, it's kind of very fine detail, but it's a dotted line because we've got this light blue input on the ramp, which is expecting a single float value. But our color, our CD attribute is green, which is a vector. So just to make this a little bit more just explicit, I'm just going to throw down a vector to float, so I can grab one of the components of this RGB value and see it converts it into float. I could take any one of these values; it's not going to matter. So wire that into the ramp, and then wire the ramp back out to color. And the ramp by default is set to grayscale values. I can't really modify it here, but if I hop up, it is now a parameter, and I could just select similar colors over here to kind of visualize that temperature again in post. This is just for visualization. We'll be doing all of this in the shader later. So if I highlight that, is that going to show up or what? Let's see here. Highlight it. Nothing. Hide other objects. Not happening. I think this might be a GL issue. Yeah, it looks like what's happened is it's sometimes OpenGL will store some information on the screen and you can't get rid of it. So if I say hide other objects, it's not going to work. But what I'll go over to do is I'm going to go up here and hit this plus icon and say new scene view. And then I'm just going to close it. Go back to this scene view, and it seems like it has jostled whatever loose was causing that issue. I'm going to go back to my camera, and I just want to play this down to see what our sim looks like. Nice. It's a little bit slow because it's got to load all these. It's got to load these files off of the disk. So what I'm going to do is actually let's just flipbook this real quick. So I'm going to click down here, say flipbook with new settings. Choose the size. Make sure it's set to 1920 by 1080, and the output is from render RF start to RF end. That's just the frame range start. And that's done flipbooking, so let's play that down. And that's looking like a lot of fun. But it's going to look like even more fun when we add our particle system on top of this. So the way we want to do our particle system is we want to actually take the emitter that we used before, and we want to emit particles from it, but then we want those particles to be pushed around by this velocity field that we have created here. So we do have a velocity. If we look if we go up here on our pyrocache, you can see that we've got this vel x, y, and z attribute that exists right there. We can use that to drive our pop sim. So let's go out to the object level and just create a new DOP network. So we're going to throw down a DOP net, and this is going to be our pop sim. So let's jump inside here. And what I'm going to do is create a pop solver. I also will need a pop object. And I'm going to need a pop emitter. Oh, a pop source. All right, so for the source, let's just wire this in. So the pop object goes on the left, source goes on the right, and they both go into output. And by default, if we go back to frame 0, it's doing nothing because there is no pop source. So let's grab our emitter over here. We're going to grab the base emitter here and just drag that into the SOP field on our pop source. And you can see that that is creating particles for us that are moving through space. I'm just going to get out of the camera so we can see what it's doing here. See, that's creating particles like that for us. It's by default set to scatter on the surfaces, and it's making looks like 5,000 particles per second. So I'll just leave it like that for right now, but we might want to change that later. In fact, I'm just going to increase this. I can already tell it's not enough particles for what I'm interested in, so let's do something like that. 20,000 particles, and it's just emitting them into the scene. So I want to actually move these particles around, though, using that velocity that we had. So we can do that by actually grabbing that velocity field and attaching it to our pop sim using pop advect by volumes. This is one of my favorite nodes, and this really is sort of like the beginnings of the concept of what what flip simulation or fluid simulation is based off of. A flip simulation, later on when we talk about it, is actually based off of a hybrid particle and volumetric solve, and so we get some particle calculation that goes on, and then some of the calculations is done based off of a fluid sim or a volumetric simulation, and then that data is transferred back to the particles, and it updates the motion and creates a very cool looking and very realistic looking water effect. This is really sort of the fundamentals of how that works. So it's important, I think, to understand at least a little bit of this concept before getting into flip, because this is really kind of the center of how it all works. And this is a really cool way to basically get all of your sims to sort of act like they're all a part of the same universe. You can tie them all together. If I was just emitting particles and they were all traveling in random directions, that would not really be interesting in the context of what we've already done with our pyro. But because we have this pyro sim and we've created this velocity field, we can use that to create and drive other simulations, which is really awesome. So let's go over here and let's get our volume velocity. So I'm going to actually just bring these points up a little bit, and I'm going to put in a null after our cache just to denote that this is our pyro. And over here in the pop advect by volumes, I'm just going to drop that pyro into the SOP here. You can see the field name that it's looking for is vel. If I middle mouse click over here, we've got those vel fields, the X, Y, and Z velocity fields. And if I go back now and click play, you can see that those velocity fields are starting to apply some force to these particles, which is kind of cool. Now, the way that the force is applied, if we use these different advection types, we can get different types of effects. And they can be kind of hard to understand, but basically using update force is more or less using these velocity fields to accelerate the particles in certain directions, but it won't actually like necessarily, it can change the course of the particle, but it's not going to necessarily slow it down. Velocity is actually going to copy the velocity of these volumes onto it and change the velocity, so you get a slightly less divergent result, and then position even more so. So it's going to be hard to kind of see the difference, but if I do update velocity here, you can see that those particles kind of they move a little bit more exaggeratedly, but they also kind of, it's hard to tell right now, but they kind of remain with the sim a little bit tighter. The other option, update position, the particles will appear to move even more rigidly through the simulation. What I found worked good for this particular setup was the update velocity method, so we're going to do that. And the other thing that I wanted to do, if I just go back here, and I'm going to just show the shoe animation, and so that when I'm inside here I can say ghost other objects and the shoe is showing up. I just want to see how these particles are behaving with respect to the shoe, and we'll see that the particles are kind of flying out of the shoe, which we don't want. So I'm actually going to apply a kill field based off of the shoe that kills any particles that leave the shoe itself. So I can do that underneath the pop source. I'm just going to throw down a pop kill, and if I add the shoe null right here to this pop kill, I'm going to choose the bounding tab here. I'm going to say enable a bounding object, And I'm just going to put the shoe in there like that. And so that's basically killing everything inside the shoe, much like how we did when we inverted the collider for the volumes. We're just going to invert this, and it's got a little checkbox for us. It's going to invert that. I'm going to turn off the guide so we don't have to see that anymore. And then if I click play, we can see these particles are being advected along with that volumetric that we did earlier. And you can see that those particles are beginning to fill down the shoe. Like that. It's looking pretty cool. It doesn't look like much right now, but what I ultimately want to do is create some trails out of this. So let's create a little area where we can import the data from our PopSim and start to do some sort of modeling on these particle simulations that we're doing. Just going to turn off the shoe animation and throw down another geometry. And I'm going to call this trails. So let's dive in here. And I'm going to call this, let's do a, we're going to need to use a dop import. So dop import. And we're going to want to grab stuff from the PopSim that we're doing over here. So the dop network that we want is the PopSim. So I'm just going to drag that up here. And it says PopSim, so that's good. And the object mask we want to use is the object that we're doing, which is this pop object. So I'm just going to copy that text of this label right here. Copy that and paste it on in where it says object mask here. And then if I say hide other objects, we've got our pops right here. So now if I, it's not going to do anything because I've got to say fetch geometry from dop network. And now we've got those particles over here doing their thing. So now what I'd like to do is actually apply a trail to these particles so that we can kind of create some cool geometry, some sweep geometry. Before I do that, I just want to be super careful here by, let's just throw it on a pop, throw it on another file cache. In fact, what I'll do is I'll hop over to the Pyro import. I'm just going to copy this Pyro cache file and throw it in our dop import over here, but we're just going to change it to pop cache. This way we can just, have this saved out so we don't have to worry about it. It's yelling at us because it can't see the file that we're trying to access. So I'm just going to hit save to disk and boom, there our files are written out to disk like as fast as that. So that's awesome. Now let's do some trail stuff. So to do the trail, I want to create a trail node. And trail node, I'm going to set for it to sort of, instead of using it to compute velocity, we're actually going to use it for what I think its main intention is, which is to make trails out of objects. And so now you can see that if I increase this trail length to something like 10, we get this sort of, our particles sort of have trails to them. Let's zoom in here. You can see they're kind of playing back. It is having an issue because the trail, prior to frame 10, the trail doesn't actually have any geo to work with based off of this pop cache. So I'm actually going to throw down a time shift and clamp it. So because this trail is trying to look back 10 frames into the past to generate its trail, it doesn't know what to do because it can't find any files that are below 1. So if I throw down a time shift and just set it to clamp to both, it makes it so that we're unable to read any files that are below 1. It just says if the frame number is below 1, just give us back frame 1. And we could change that range if we wanted to, but we're just going to leave it the way it is right now. So this trail is basically at this point just echoing all these points. So we want to find a way that we can actually add polygons to this. So let's throw down an add node. The way we do this is with an add node. And if I highlight that, and we go to the polygon section and we say by group, by default, it's just adding all this. It's kind of just running a sweep, I think, through all the points that are visible, which we don't want. We can actually have it add by attribute. And because our pops add ID attributes by default. If you middle mouse click on our cache, you can see there's an ID attribute here. That means it's a unique point for each point. And because we're just simply trailing these points, if I pull up the geometry spreadsheet and highlight the trail, you can see that we actually get multiple IDs for each point that's been trailed. It still has its own unique ID based off of its trail. So really this trail, this ID is really acting like a trail ID. We can go into our add and just use that ID to make those trails exclusive to their individual parts, or to the individual points that are creating them. I'm just going to throw down a color to make this a little bit easier to see. This color, since everything's white, but if I take this and I do another random from attribute based off of ID, we get individual colors for each one of these trails, so we can kind of see those in action. Let's go back to the camera and see what we get. We get this kind of cool trailing effect where all these particles just kind of bursting out and moving across the geometry like so. Now, there are some points in here that look pretty coarse because maybe they're moving really fast or something. Like up here, they're looking very straight. If I look at the points, you can see that some of these points are getting really stretched out. So what I do to kind of combat that is to throw down a resample. So I'm going to throw down a resample node, and I'm going to set the resample to a really small length, like 0.02, maybe 0.002. And then set it to do subdivision curves. So now we get some smoother lines. So the next thing I might want to do is actually add some sweep geo to these polylines. So I'm going to do that by throwing down a polywire. But before I wire this in, the polywire, it can get a little bit overloaded and can be kind of hard to see what we're doing. So what I want to do is just isolate maybe one of these wires. So I'm going to go over here and use my selection tool. I'll turn off select visible, but I'm going to switch over to primitive selection mode. I'm just going to select one of these strands and hit the delete key. You can see that that has deleted that by throwing down a blast node. I'm just going to delete non-selected so we can isolate it and just take a look at this one strand. So now if I wire this into polywire, you can see by default polywire is gigantic. So we're going to want a much smaller wire radius, maybe something like 0.001 as a starting point. But we're going to want to control the width of this polywire based off of the length of the curve. So to do that, what I'm going to actually do is on the resample here, I'm going to activate the curve view attribute. This curve view attribute is just about a value of between 1 and 0 that runs along the length of the curve. So what I could do is now create a point VOP to modify the p-scale value based off of the curve view value. So I'm going to throw down a point VOP. I'll just throw this in right here, and I'm going to rename it to control the width. And let's just jump in there. I'm going to bind. And I'm going to bind in the curve view, the attribute that was created. And because it's a value of 0 to 1, it's already like in the normal range for us, which is good. I'm just going to feed it through a ramp parameter. So I'm going to wire this in here. The ramp that we want to use, we want it to be a spline ramp. And we'll call this width ramp, and I'll label it width. DTH width ramp, like that. And then we don't want it to control any of these, but we do want it to control p-scale. We'll use the p-scale attribute to drive our polywire. So bind export, and we'll call this p-scale. And run our width ramp into that. Hop out here, select our polywire, and instead of the wire radius of 0.001, we're going to type in @p-scale. And now it doesn't know what to do. Let's see. That's because our width ramp is on a basis of 0 to 1 still, and so we're going to want to fit this because this is like insanely huge and super sensitive. So if I just put down inside of our point VOP here, we'll put down a fit range. And just bring that in after the width ramp. This is going to range map the width from a value of 0 to 1 on the incoming to whatever we want it to output as. And for our case, I want to promote these parameters so that we can use them on our interface up above. So I'm going to middle mouse click on dest min and say promote parameter, and same on dest max, middle mouse click, promote parameter. So now when we hop up here, we get these two guys down here where we can control how much that width ramp is affecting our stuff. So I like to have full control. I like my maximum values on my width ramp to really correspond with the maximum values. Just because I find that it's easier to control this when I have more vertical latitude with it. So I'm going to bring down that maximum value on my actual on my fit range here to be something like 0.002. So something like that. So you can see we're able to just sort of kind of sculpt the shape of this sweep based off of this ramp. Now I'm going to modify this a little bit. Let's do maybe over here. I'm just going to select all of these and choose to, I'm just shift selecting these notches. So I grab all of them, and we're just going to switch this to B-spline down here. And then maybe I'll add in some more points. Bring this one out a little bit. Maybe have it get sharper. This is really sort of just kind of shaping it a little bit more. I'll bring this in a little bit so we kind of get this organic looking shape. Maybe I'll add another bulge at the end here as well. So it's sort of this like almost organic, like I don't know, almost looks like a worm or a leaf or a branch or something like that. I'll go with something like that. I really like how steep this is. I might bring this one in too and bring these guys tighter so that it really kind of has that sort of like a spade look to it. That's looking cool. And yeah, let's go with that for right now. So that being fed into our polywire, now let's see what it looks like with all of the geo. So I'm going to turn this off. I'm turning off the blast, and it's going to polywire all of our points. You can see that it's creating some pretty cool looking shapes. It's like branching style shapes, which is cool. I'm going to add a normal after this, just because I want them to be a little bit sharper. Everything looks, on the polywire like it's very smooth and rounded. And I actually kind of like how the polywire itself, when we had the blast on, I kind of like how this has that very harsh edge on it. So by adding a normal after the fact, I can kind of ensure that that's going to work properly. Like that. I think also another thing that I want to kind of explore or mess around with at this point is sort of what the timing of all of this is going to be. So let's go back up here to the section where we have our resample, and I want to actually bring up the let's just hide the pop sim, bring in the pop import, and have these both sort of overlaying one another. You can see that these trails are just totally overcome by what's going on with the shoe simulation. So you can see that they're almost like they're right on top of it. Now I could use a time shift to actually offset this a little bit. So I'm going to, after the resample, throw it on a time shift. And I'm going to make it so that I have all objects visible, and then I'm going to just offset this time shift until I find a point where I like the separation we have between these two sims. So basically, I'm going to subtract some frames, or add some frames rather. Let's just try adding 5 frames. I'm going to add 5 frames to my trails sim, so you can see the trails kind of hop out a little bit ahead. That basically means that the trail sim is 5 frames ahead of the pyro sim, which is looking cool. I might give it some more room to breathe, maybe plus 10. See, something like that. Just the trails are just a little bit longer, and then they're almost sort of being gobbled up by the pyro sim as it comes along and helps fill in. So that's kind of cool. I want to also just check and see what things are looking like from my camera angle. At first, it looks like the trails are actually kind of on the verge of outrunning a little bit. I kind of want them to be a little bit not so far along on this first section here. So maybe if I were to, dial these back, I could actually get a better result. So I think what I might do is actually create my own parameter and animate how much this frame offset is going to actually occur. So I'm going to set this back to $F, just the way it was. And what I'm going to do is create a parameter. So I'm going to hit the gear here and say edit parameter interface. And then I'm going to select a float and pop that over here. And we'll call this offset. And we'll label it offset as well. And hit apply and accept. So now we have this offset over here we can animate independently. So let's do this. I'm going to right click, copy parameter, and up here I'm going to add this to the frame instead. So I'm going to add a plus here and then say paste relative reference. So now if I click on frame, you can see it's going to evaluate to whatever I set this value to down here. So maybe on the first frame, we set this offset. I'm going to just set it up to maybe a value of 1. Or let's see, until something at least shows up in the first frame. So maybe we start with an offset of, 2. I'll set a keyframe here. And then by the time we get to frame 24, I'll bring this offset up to 10. So it's going to sort of start all at once, and then it's going to eventually offset its way so that it's, reaching out ahead of our pyrosim quite a bit. So to create the color for our polywires over here, just for visualizing, I'm gonna jump over to our pyro import and just grab this point VOP we created here. I'm gonna name it color, and I'm gonna just Control C and then hop over to this network and hit Control V and wire that in here. If we go to it, it looks like it's just coloring every fiber individually. And I actually want to use the curve U attribute to color these fibers again. Again, it's taking the incoming color since we had already set those random colors. Up here, it's remapping them. And now that I turn that off, everything's just turning up to be pink. So let's get back into our PopNet here and just have it be driven by curve U. So we just want to bind in that curve U attribute again. So bind curve U, and then we're going to feed curve U through the ramp instead. Then we can delete that vector to float. We don't need that anymore. And if I hop out here, I can modify this range and get cool different color like effects. So now if I turn on my polywire, I'm able to change the color of this. You can see that actually changing this color is taking quite a while, because every time we change the color, that attribute is being read in, and then it has to be refed through the polywire. So I think what I might do actually is just shake this off. And because polywire inherits the attributes and the curve U attribute isn't changing, I'll just wire this in afterwards. So now when I modify the color, it all happens very quickly because the geo is already baked. So now that I've got this, what I'm going to want to do is actually, I'm going to do the same thing like I did up here. I just want to cache out this polywire function that's being done here. So I'm going to do that. I'm going to just bring the normal back up here so I can cache that along with it. And I'm going to just throw down, so let's just throw down a another file cache. In fact, I'm not going to even create one. I'm going to just copy this one from up here, the pop cache, and bring it down and hit paste. And just wire this in right after our normal. And I'm going to rename this one the trail cache. So now if I highlight that, I'm just going to run this through real quick so that we can have this saved out to disk, and so that it plays back much faster. All right, now that has stopped, finished caching, I'm just gonna tick load from disk, make sure that's ticked on, like so. And it is, even though it is still pretty slow, I mean, this is pretty high poly what it's loading, but it's at least faster than what we had before. So now let's just turn on the color, and let's go over here. I've got these. We've got the the pyro surface and we've got our trails. Let's just combine them two. Let's just combine the two and view both of them together in a quick play blast. So let's throw down a null. I'm just going to call this the trail. And over here, another null. And call this the pyro surface. So back out here in SOPs, both of them appear at the same time. And I can now run a flipbook. So let's do a flipbook with new settings. And RF start, RF end, cool. 1920 by 1080, good. Let's click start. And I'll be back when this is done flipbooking. All right, so that flipbook's done, and this is what we got. So it kind of looks like this almost like a tropical, I don't know, shoe, palm tree, feathered bird type thing that is kind of blooming out of nowhere, and I'm digging it. So now we just got to export this into Cinema. So I'm going to stop that, and let's just minimize it for now. What I want to do to export this is we're going to use an Alembic, and we're going to bring both of these into the Alembic and merge them together, name them so that they're separate objects in Cinema. So the first thing I want to do is I want to strip the color information back to grayscale values so that I can use that grayscale values to drive, use those grayscale values to drive a ramp over in Cinema. So let's first do it for our trails. Here where we have our color set, this is for our color. I'll just call this for color viz. And then I'm just going to option drag another one off to the side. And this one will be actually our color for real, for realsies. So actually I don't really need to dive back inside there. I'll just throw it on a switch and wire that in here. And for our color, our actual color grayscale, we'll call that. I'm going to just switch this from a black value over here on the left and a white value on the right, and then just grab that middle knot and drag it away so it disappears. So now if I switch my switch to option number 2, now we get this grayscale value that we can use to drive a shader more easily over on the other side. So we've got that, and I'll do the same thing over here. We'll call this one color viz, and then we'll option drag it off to the side and call this color grayscale. In fact, I think I actually have color grayscale already up here. So I don't need to do this, but I will throw down a switch. So the switch here is, I'm going to actually just tie it to this one. So whatever switch one is, I'm just going to grab this and drag it over to that one and say paste relative channel references. So now if I can say show all objects, if I just grab one of these switches and switch it, it should switch the other one as well. So if I have this switch selected, so I go back to this guy, switch it on, and it turns off that color on both the surface and those trails. So nice. Now I want to go over to create another geometry node, and this is going to be where we export our Alembic files. So we'll call this the export. And in here I want to get a couple object merges. So let's do object merge. And I'm just going to option drag it off to the side, or alt drag it off to the side rather, to just have 2 of them. But I'm going to name one of them the trails. And I'm going to name the other one the pyro surface. And so I'm going to select the pyro surface and drop the pyro surface null in object 1. And then under the trails, maybe I'll just select the trails null that I created there. And hit accept. So now if I merge these together and say hide other objects, I should get what we had out when we're in our main view. Brings both of those together, looking good. Looks like there's not any normals on our pyro surface, so that's why it's turning black. So maybe at this point I think what we could do is actually, well, I'll come back to that in a second. What we're going to do is we want to actually create an Alembic out of this. So we're going to want to delete a lot of these attributes out of here that we don't need, and also name them appropriately so that our Alembic file can sort of segment these out into 2 separate pieces of geometry once we import them on the other side. So First thing, let's name the two. So I'm going to throw down a name null over here. This one, we're going to call this, we're going to name it trails. And I'm just going to alt drag this over here and throw that on there. And we're going to call this the pyro surface. You can see that it is basically just, if we go down to our merge here and look at our primitive attributes, we have a name attribute that is set to either trails or pyro surface for all of our stuff. And our Alembic file can read that. So if we go to Alembic, create a ROP Alembic output, and wire this in here, you can see that there is under our geometry, under the hierarchy, there's the ability to build this hierarchy from attribute. So I can tick that on, and then it's looking for a path attribute. We can actually set that to the name. The name that we just created up here will be used to generate a hierarchy inside of our Alembic file. Nextly, I want to get rid of all these attributes that we don't need. So basically everything except for color. So I'm going to do an attribute delete. And wire that in here. And on the attribute delete, I'm just going to select the attributes that I don't want anymore, which is everything except for color. So I'm going to hit the star key. The star will delete everything, but the caret will say except for the CD attribute. Don't want any vertex attributes, don't want any primitive attributes except for the name attribute that we just created up above, and I don't want any detail attributes. So now if I middle mouse click on this, you can see we got color, position, and name, and that's all we need. We also have these groups left over, which we don't need, so I'll just throw down a group delete and leave that in here. Well, I'll put in a star to delete all the groups, so we don't need those anymore. So those are gone. So now let's export this Alembic file. I'm going to select it, and let's make another directory for ourselves. So before we had our ABC to H folder for the ABC file we exported from Cinema. So now we'll do ABC to C4D, and then I'll just name the file based off of the hip that we are working in. So hip name, $hip name.abc. And just to make sure, if I come down here to this group delete, I'm seeing that we're still getting this kind of smooth geometry look here, which I don't really want, but I'm wondering if I can't control that on the Cinema side or how it's coming in on the Cinema side. So I'm just going to test real quick what we're getting before caching out this whole thing to an Alembic file by just caching out one frame. So if I select the hip file here, and by default it's set to render current frame, I'm just going to click Save to Disk. And then we'll just look at what we get in Cinema. So I'm going to go over to Cinema. I got a blank project here. So I'm going to go navigate to my project directory. And you can see here we've got all of our nice cache folders that were all created for us using our tokens and everything. And we got our ABC to C4D. And inside here is our little ABC file. And there's an old backup file in there from an old version of this, but if I just drag it over here, and let's just increase the scale to 100 centimeters so it appears to be at Cinema size, since we didn't really do any scaling in Houdini to compensate for the fact that it's in meters. Everything else I'll just leave it the same, so say OK. And here our geometry comes in. You can see that it's created a trails group and a trails geometry and pyro geometry for us. That's cool. It looks like it's also creating a hair primitive for us, which we don't need. That's likely due to just some extra splines hanging around that we don't really need. So I'm not going to worry too much about cleaning that out right now. I'm just going to delete it. But we can see that we've got our color maps here. So if we click on our vertex map for the trails, we can see that we're getting color on all of our trails, and also down here we're getting color on that pyro surface as well. So that's looking like it's working out good. So now I'd say we're ready to actually export this as a Alembic sequence. So I'm going to close this and switch back over to Houdini and write this out. So we're going to say render frame range and hit save to disk. and I will be back when that is done. Alright, so that has finished caching out. I'm going to open up the original project file we had. So let's go to Open. I'm going to navigate to the project folder and select the Start project. Open that. And I'm just going to save this as the end project now. And I'm going to bring in the Alembic file. So let's say File, Merge. Navigate to our ABC to C4D file, grab our 5 gig Alembic that we created, and I'm going to scale this one up to 100 centimeters. And I'm going to delete out the hair trails that it created. We don't need those. And I can hide the shoe now as well. And with enough luck, if I scrub through this, we're getting all that geo here in Cinema. Great. Next thing, let's just hook up our shaders so that they're reading that color information from our vertex maps here. So I'm going to create a new, I'm going to actually delete this hair material, don't need that. Let's create a couple redshift materials. I'm going to create a new redshift material and just control drag it off to the side. So I'll call this one the Pyro Surface, and this one will be the trails. In fact, I might not even need 2 trails, so I'll just work with the Pyro Surface first. And I'm going to we'll work with the trails first. I'm going to throw the trail shader on the trails like this. And just going to double click to bring up this, the attributes down here. And then I'm going to say Edit Shader Graph. And what I'm going to do is grab the color. So I'm going to go and throw down a RS. It's going to be a attribute, RS vertex attribute, and I'm going to drag in the trails color vertex map right into this attribute name right here. And just to see what's happening, I'm going to drag this in and map it into the diffuse color. So it doesn't look like, it looks like it's all purple right now. But if I throw down a ramp, I should hopefully be able to remap this. So let's just throw this color ramp in here and in here to, I'll just map that back into the diffuse color. And let's just change these values to something like what we had before. So we'll do, the cool color is going to be this blue. And then the hot color is going to be this pink. And in between, we'll throw down something purple like that. And we're not going to really see anything in the viewport. But let's get a render going to see what this is looking like. So Redshift, open up the render view. I'm just going to disable the Pyro surface for right now. And click render. And my computer really can't handle rendering and recording all these streams at the same time. So I just had to stop the recording and come back here. But you can see that now we have those vertex attributes mapped onto our shader. And we can start lighting and shading and making this look all fantastical. Additionally, suppose you wanted to do a little bit of work and add that the actual cloud volume that we were creating to your Cinema 4D scene. We already have pretty much everything we need to export that. We just got to pop into our Pyro import here. So I'm going to actually just collapse this right hand side down and bring this up a little bit. So here where we cached out our Pyro cache, just going to click on that, and I'm going to choose Hide Other Objects. And we see we've got our volume visualization right here. And this is sort of a density volume coming in from our PyroSim. If we wanted to export this to use in Cinema, we could do that here as well. If I just crank this value up, you can really kind of get a chance, get to see what it might look like in a viewport preview. But we could actually just write out a VDB from here. So I'm gonna pull off a little. I'm gonna pull off to the side here. I'm gonna do a convert. Actually, what I'll do is I'll blast density. Because we're only going to bring over the density. I suppose you could bring over temperature too if you wanted to. So maybe what I'll do is say bring over temperature and density. Those are actually what's being deleted from our group. We actually want to keep them and delete everything else. So here you can see we've got density and temperature coming through here. Then I'm going to convert VDB, which converts them to a VDB. Right here, I just say convert to VDB, and we've got these two blue VDBs here. And then what we could do is say throw down another file cache. Actually, I'll just copy this pyro cache here, and I'm just going to call this VDB out, or just let's say pyro VDB. And I'm actually going to change the location of this to a VDB folder. So I'm just going to write out VDB here. And so we've got our VDB that we've created here. And then we're going to just be running it out to this VDB file. But I'm going to change the extension to .vdb instead as well. Because these are VDB files. And they need to be, the extension needs to be VDB to be readable in Redshift or Octane or whatever program you're using. So now that we've got that here, one more thing I'd like to do before I cache this out is I'm going to write this to a 16-bit file. So the way I do that, and it saves a ton of space. So if I throw down a primitive, oops. This gives us the opportunity to just kind of optimize our volume a little bit. So under the volumes tab here, if we choose the VDB right here, we can tick this box at the bottom and say write 16-bit floats. This will make the file size just much smaller. All right, so I'll just click save to disk, and it should go relatively fast, but I'll be back when that's done. All right, so that's done caching out. I'm just going to switch over to, I just want to pull up my project folders here. So this is, let's just compare this pyro cache to this pyro VDB that we just wrote out. So I'm going to bring over this right here and this. So this is our original pyro cache that we wrote out. You can see that these VDB sizes are massive. They're almost 600. It looks like it's 622 megs for the last file, which is the largest one. Over here, after converting it into a 16-bit float VDB, file sizes are baby compared to that, a factor of more than 10 times smaller. So stripping away those velocity fields and changing the bit depth of the VDB really makes it a lot more efficient to store this on disk, and also it'll make it a lot easier to read back once we're in Cinema. All right, so let's get these guys into Cinema. Let's go back over to Cinema here, and I'm just going to, on the Redshift menu, I'm going to say a new Redshift object and then choose Redshift volume. And then I'm just going to point to that object. So going back up here to lesson 10B, this VDB folder and our Pyro VDB, and that one right there. It's good. Asks if I want to import it into the project location. No, it's already in the project location as far as I'm concerned. So that's all good. I'm just going to go over to the animation tab and select simple and change the frame rate to 24 to match my project and hit detect frames. I'm going to get frames 1 to 72. I'm going to go to the coordinate system here and scale everything up by 100. And that kind of fits in the region of where our trails and everything were. So I'm just going to leave the trails and the other stuff off. But now what I need to do is get a shader on the Redshift volume. So I'm going to throw down a new Redshift volume material under this menu, and then just put that on our Redshift volume here. And I'm going to go down into the Redshift shader options and just add density to this scatter channel. And then let's just fire off another render real quick. So I'm going to open up my Redshift render view. and hit the play button. I'm going to just decrease the scale here to 50%, just so that it previews a little bit faster. You can see that our volume is coming in that we brought in. Now, in terms of lighting it and shading it, we don't have any lights that are contributing to volumetric scattering in this scene, so I might grab these area lights that I added in between lessons and go to the volume and increase the contribution scale a little bit. Maybe I'll just bring it up to, maybe something like 0.7. You can see that this area light on the left hand side over here is starting to light that volume. It's looking cool. And we could even just mess around with this shader as well, like cranking up the density of it, changing the overall tint of it to be something more along the lines of the color scheme that we're working with here. And maybe the absorption is brought down, or maybe brought up. I don't know. Whatever you want. And so that would sort of be the way that you would go about bringing your actual VDB volume into Cinema 4D if that was what you're after. So I hope you enjoyed this lesson. I thought that it was kind of fun to just take volumes and use them in these sort of unexpected ways, these kind of abstract growth-like ways, and using them to drive particle systems, because it's going to all kind of come together in the next chapter, which is we're going to talk about flip simulation. And flip, to me, is one of the more complicated parts of Houdini because it actually does combine volumes and particles together in one giant physics simulation that is totally amazing. So stay tuned, and I'll catch you in the next chapter when we talk about flip fluids.